Okay, chapter 3 summary and review. So we have our different types of angles. We have our 0-degree angle, our acute angle, which is less than 90, a right angle, which is exactly 90 degrees, obtuse angles, which are greater than 90 but less than 180. Exactly 180 is a straight angle. Then we have our reflux angle, which is greater than 180 but less than 360. And then if it goes all the way around, it is exactly 360 degrees. We have opposite angles, which is another name for vertical angles. They will be equal. Complementary and supplementary angles are adjacent angles because they are next to each other. But if these adjacent angles measure to 90 degrees exactly, they are called complementary. And if they measure to exactly 180 degrees, they are called supplementary. We have our addition property. So if A is greater than B, then A plus C is greater than B plus C. So since we added the same to both sides, it still maintains the same equality. Then we have our subtraction, which is exactly the same. If A is greater than B, then if we subtract C from both of them, it will still be the same. Multiplication. If A is greater than B, then AC is greater than BC, as long as C is not 0. The division property, we have A is greater than B, so A divided by C is greater than B divided by C. So same type of thing. If we start off with the same values and divide it by the same number, it'll still maintain the same equality. We want to make sure you know that an axiom is a synonym for a postulate, and these are true without proof. These are different from a theorem, which need proof. So postulate is true without proof. A theorem needs proof. One of those theorems is the betweenness of points. So a point is between two other points on the same line if and only if its coordinates are between their coordinates. So we have B between A and C. And so betweenness doesn't mean it has to be exactly in the middle. It just means it has to be between. And so if you took A plus B and B plus C, these segments, you would be getting an equal number to the distance of the line segment AC. We have the betweenness of rays theorem, which is exactly like the betweenness of points theorem, except that instead of a point between a line, we have a ray between two rays. So OA is on the left, or on the right, OB is in the middle, and OC is on the left, and the middle ray is OB. And if we added COB and BOA, it would equal our total larger angle COA. Okay, let's see how to bisect a line segment. So first you start off with a line, you put your endpoints, you label them. Then you want to open up your compass to a distance that is about 3/4. Plant that in here. You're going to make, let me move my screen down. You're going to move an arc at the top, and while it's still connected to the bottom, make an arc at the bottom. Oops. Then you're going to grab this, keeping it at the same distance. Cross that. Oh, the top one didn't quite do it, so let's do it again. We gotta go a little lower. There we go. Then we take our ruler and we line that up. And now we have bisected our line segment, and we have nice 90-degree angles. Okay, now we're going to talk about how to bisect an angle. So if you start with an angle, what you're going to do is you're going to open your compass to about halfway to one of the legs. So you don't want it all the way out here, and you don't want it so tiny, so about halfway. So you're going to go all the way, actually I'm going to make it a little smaller, all the way across. And then you're going to take your compass and you're going to measure. See how it's not quite the distance all the way across? So you're going to measure the distance across from one ray to the other ray. Okay? Once you've done that, you're going to pick up your compass and you're going to draw a little arc. Then you're going to take it and place that point there, draw an arc. And now you're ready to draw your line bisecting your angle. This is equal. Great job. Okay, and then we also want to talk about, we have adjacent angles which are next to each other. We already talked about that. They're sharing a common ray side. We have vertical angles which are across from each other and always going to be congruent. We already talked about complementary angles which add to 90 and supplementary which add to 180, but just to be sure, we're going to say it again. Congruent means that two shapes, if they were superimposed, that means lined up exactly on top of each other, they would be having the same size of sides and the same measurement of angles, exactly the same. A corollary is something that results from something else. So it is a synonym for a result or an outcome. So the acute angles of the right triangle are complementary, right? So we have a right angle, and then these two angles are acute and they're complementary, meaning that they add to 90. And so that is our conclusion, that if we added angle D plus angle M, it would equal 90 degrees. Linear pairs are two adjacent angles that add to 180 degrees. And so a linear pair is the same as a supplementary angle. We have the midpoint of a line segment, and a midpoint is not the same as the betweenness. A midpoint is meaning exactly in the middle, midpoint. So that means it would be equal on the left and the right of this midpoint. Opposite rays, if we use B as the center of our array or our line, that means that we would have a ray going from this to the right, BC, and we'd have a left ray going to the left from BA. And both of these rays are sharing the point B, and they are going in opposite directions, so they are called opposite rays. We have parallel and perpendicular lines. And the reflexive property is kind of a property that we already just know instinctually, but it says that any number equaling itself is itself. So it's like a reflection. Substitution property, if A equals B, then that means if A plus 3 equals 8 and B, we could plug B in for A and say B plus 3 equals 8. Then that means A equals 5 and B equals 5. So A equals B and 5 equals 5. The ruler postulate is a really fancy way of saying you can use a ruler to measure, and a ruler coincides to measure things in an order, kind of like a number line. Also, we have the protractor postulate, which means you may use your protractor to measure an angle. Okay, that's it, guys. Hope you're ready for your test. If you have any questions, send me an email or talk to me in class. Bye.